Screen, and when I can find a keynote. There we go. So, hello, good afternoon, good morning, good evening, depending on where you are. My name is Will Yates, and as Josh said, I'm a senior technical staff member for IBM. I've been working on a product called CICS, or if you're in America, that's CICS, because for some reason they decided to pronounce it. No one really knows why, but they do. And we're going to be going over what it is and why should you care about a product that is over about 55 years old. Why does it matter? What does it mean? But first, we're going to start with a question. What is the size of a fridge and runs transactions? Now, you're all on this Z Ambassador course, so you're probably going to think, oh, yeah, it's a mainframe, we know. But no, it's not a mainframe. That's not the answer I'm looking for. Instead, the answer I'm looking for is a vending machine. Now, you should all be very familiar with one of these devices. I'm sure you've come across more than one of them in your lifetimes. Very simple idea. It has snacks. You want snacks. You give it money. It gives you snacks. Very straightforward. But the idea of getting a snack from a vending machine is rather transactional. Let's think of it this way. We have a start condition. The start condition is that I'm hungry and I have money. And the vending machine start condition is that it doesn't have any of my money, but it does have snacks. And we want to go through a series of operations to get to an end condition where I have perhaps a little less of my money that I had at the beginning, but I now have snacks. The vending machine has a little fewer snacks, but has some of my money. Very simplistically, I want to go to the vending machine. I want to enter on the buttons what I want. I want to give it my cash, and I want it to vend me some snacks. What we don't want to have happen is for anything to go wrong during that sequence of steps. Now, if something does go wrong, we have to move, or the vending machine has to take us back to the start condition. So let's say I put some money in, I select the item that I want, the little twirly things twirl, but my snack doesn't get properly dispensed. The last thing we want is for the machine to have kept my money and not given me snacks, because that would be a terrible scenario. What we want is for the machine to go, something as bad has happened. What we should do is we should return back to the start condition. And the best way of doing that is usually just to refund me the money that I've already entered. What we don't want is for the machine to somehow get very confused and it ends up with all the snacks and all of my money. This interaction with a vending machine, although, yeah, okay, it is simplistic, is the driving kind of force behind a transaction. And transactions are at the heart of what CICS as an application does. Let's put a bit more theoretical language around this concept of a vending machine. As we said, the core feature of a vending machine is this of transactions. Through a sequence of operations, I give the machine money, it gives me snacks. And those transactions can be considered as acid transactions or have the acid properties, namely atomicity. And what do we mean by atomicity? So the process either succeeds and we can sync point the transaction, we can sync point that unit of work, that sequence of events, and we've got to a successful outcome, we can sync point and commit that transaction. So you can't get your money back. Enjoy the snack. There's no reversal once we've got to the end of that sequence of steps. But if the process fails, then we can roll back the transaction to its starting state and potentially try again, have another go, see if it works the second time. And that takes us to the point where it's almost as if the failed transaction never happened. We've gone back to our starting point. I'm just trying to get rid of the... Okay, that's not going to work. But this machine is... this vending machine only happens or only executes these transactions sequentially. one by one after the other. If two people try and use the vending machine at the same time, that's just not going to work. We need them to work in sequentially. It has to be done in a single threaded manner. Now, that kind of constraint is fine for a vending machine. I don't think I've ever seen a vending machine that lets 2 or 3 or 4 people use it in parallel. But it's not very good if you're trying to write transactional applications. Okay, so let's forget about vending machines. It was just an analogy. Let's move to something a little bit more important. Let's think about banks, where I want to transfer money from one account to another account, maybe within the same bank, maybe within different banks. I want to transfer X, an amount of money from A to B. What are the steps that are involved in me trying to do that? Well, I've got to read the file in account A or bank A to see how much money that user has in that account. I then need to, in memory, deduct an amount of money from that record. And then I need to rewrite that file. I need to write that amount back. That's one set of operations. I also need to read the amount in the second file. And then in memory, add the X, the amount of money I'm adding to the account, add that to the amount that I've just read. And then I need to write that amount back into the file or database. I've got a sequence of actions. And similarly to my vending machine, where we had a sequence of actions, all of these steps must succeed or we must be returned to our starting state. Now, this is really important. If you're going to an ATM machine or you're transferring some money through e-banking or through your mobile or you're paying for something, this happens billions of times a day and it always has to work. You don't want to go to the ATM and try and transfer £5 or take away £10 out of your bank account and for us to have read the amount in your account, deducted £10 from it, but then fail to complete the last bit of actually dispensing the £10. You'd be down £10 and you've never actually received the cash. That'd be terrible. But think about all the transactions that are happening daily across all of the banks worldwide. This is happening billions upon billions of times every single day. And by and large, they all work. Each of those transactions either completely succeed or they get returned to their starting state. Now, when we read it like this, we think, oh, well, we just need to make sure all of that works. But again, I'm not doing it sequentially like a vending machine. I've got to do it in a multi-threaded environment. There may be multiple threads reading from account A at the same time. My wife and I share a current account. She could be out shopping. I could be out shopping. We can both use our cards at the same time. And even if we make a transaction at exactly the same time, there's never a race condition where I end up with an incorrect amount of money in my account because we've tried to do 2 transactions at the same time. This sequence of actions also has to be done securely. Am I okay? Am I allowed? Am I eligible to transfer money from A to B? Have I entered the right PIN code? Is this a secured transaction? Data integrity, making sure that we don't have any race conditions as we're writing data or reading data to make sure we eliminate dirty reads, dirty writes. Multi-threading, being able to do this in a multi-threaded, non-sequential environment. Being able to do this at speed. I said before, billions of transactions. Well, that's not going to be possible if each transaction takes 5 or 6 seconds to execute. These have to be sub-second transactions, regardless of what technology, what programming language, or where these banks are situated. So the concept, a very simple concept of a vending machine transaction, when taken to the idea of running a transaction in a bank, now becomes really quite critical. And if we wind the clock back to the 1960s, that level of computing just wasn't possible. If you went to your bank and you said, I want to withdraw money or move money from one account to another, it was written to like a daily ledger. And then overnight in a batch window, that ledger was applied to their main account files. You all look under at least around about under the age of 30. If you're old and grey like me, you'd remember that there was a time when any kind of transactions you made on your bank account, even electronic transactions, didn't actually get settled until the batch window overnight ran. The idea of updating your account in real time just didn't exist. And so IBM developed a piece of programming code, an application called Customer Information Control System. And its main focus was to migrate people away from that daily overnight batch update to changing customer data and customer records in real time or in online transactional processing. And this was a massive change to the way that customers did business. Now you didn't no longer needed to have an overnight batch window to update things, and hopefully people still had enough money in their account. You could actually make the changes against your live production database in real time. And so our customers took advantage of this to write these types of applications that gave them a business strategic advantage over other customers that maybe hadn't adopted this technology. And over time, IBM provided capabilities to CICS to allow people to write applications in more interesting and provide more value to those applications. As Ballmer said in a very famous and very memed Microsoft Developer Conference years and years ago, it's all about developers, developers, developers. And the types of companies that were using this technology were utility companies, so electricity, water companies, banking, insurance, finance companies started to build their business on this capability. It wasn't just cute little side applications. They were building the root capabilities of what their business was to become. And they were building it on the mainframe using applications like CICS. Now, initially, the interactions with these applications were the classic green screen. If you've ever seen any kind of sci-fi film or techno film where there are hackers in the mainframe, you'll see green screens. This is the de facto image of what ZOS looked like. And the applications that people were writing in CICS were only using that interface. And this is how bank clerks would update records. So when you paid in money or took money away, they'd use an application and menuing systems on that green screen to interact with the application to run those transactions. And this COBOL application, so for those that, that probably don't know, COBOL, Common Business Orientated Language, was a language that was developed to take the programming activity away from the hands of the developers who were perhaps skilled in languages like PL1 or assembler and give it to business people. So business people could kind of codify or codify their rules of their business in application code and then run that inside of CICS. Over the years, we've seen that kind of concept change multiple times in EGL languages and quick visual programming languages to try and take the programming art away from developers and into the hands of business people. And as we all probably know, very few of those have really succeeded. But these COBOL applications would have within them code that understood the presentation logic, how to interact with the 3270 screen, as well as their business logic, how to actually do the business task that the presentation logic was trying to drive. And as capacity for this new capability, as businesses built their applications and workload started to increase, CICS had to grow to meet that capacity. So we went from just having one region or one CICS application space running on the mainframe to host an application to having multiple. There are companies now that will have upwards of 500 CICS regions within their environment to meet purely the amount of workload they are processing on a daily basis. And often applications that were written for CICS, and at the time maybe just for a single instance of CICS, could grow to run in multiple CICS regions without ever having to be recompiled or changed. But of course, over the last 50 years, we're still not using green screens. Well, some people are, but most of the world has moved away from green screens as their presentation logic. If you now go and want to inquire on your bank account, you're probably not using a 3270 dumb terminal sat in a room somewhere. You're probably using your phone. So as the rest of the computing environment grew, CICS needed to grow to allow other mechanisms of invoking applications to run that same business logic. The problem was that from a application perspective, these COBOL applications were used to interacting with a terminal and then running the business logic. Both those pieces of application code were closely entwined. You couldn't easily rip them apart. So this means if we wanted to use something like CTG or a queue or some other mechanism to invoke a transaction, we couldn't because those mechanisms couldn't speak 3270, couldn't replicate that 3270 green screen terminal. So this is kind of like one of the first major shifts we saw in CICS application programming, was the idea that that CICS program, where the business logic and the presentation logic were intertwined, needed to be separated, and separated as two separate programs within CICS. So if I was driving this business logic via a 3270 terminal, I could call my presentation logic, and when needed, that presentation logic could call the business logic. But it also meant that other ways of invoking transactions, like maybe a queue, a WebSphere messaging queue, or a Kafka queue, or CTG or TX series, could link directly to the business logic, bypassing the presentation logic completely. And it was this shift in styles of application writing, or almost a architectural change in the way that you approached writing CICS programs, that really enabled CICS to throw itself into the future and to allow these applications to maintain their relevancy as time moved on. As we started to see new ways of invoking CICS applications, of course, the amount of traffic, the amount of transactions per second that these applications were being asked to process grew exponentially. We went from basically the number of transactions you could run a second being down to the number of 3270 terminals you had available to now, well, virtual mechanisms. So how many virtual queues, how many other parts of the enterprise would be interacting with this application. And so this meant that the architecture, the way that CICS applications was structured, and the number of regions or CICS applications you had, and how they were interconnected together also had to fundamentally change. So we ended up with this structure of a terminal owning regions and application owning regions. The terminal owning region would just contain that presentation logic that we spoke about, the way of interacting with the green screen. The business logic, the actual rules of the application, will be thrown out into application owning regions. And these application owning regions could be cloned multiple times to allow you to give you some sort of scalable throughput. If you're looking at this and going, gee, the idea of actually putting your application logic into a cookie cutter kind of container and scaling that horizontally, that's starting to sound a little bit like Kubernetes. It's not 1,000 miles away. The architectural similarities are very close. But it also meant that if we now needed to have other ways of driving that application, we could then create new types of CICS regions to run different presentation logic. In the 90s, we went through a little bit of a hill of people writing web interfaces. And as HTML became kind of the new thing. And so people created web owning regions for their CICSes, which would link directly to the business logic as they needed to. Now we have APIs, and so you may have API owning regions or API concentration points, which are just CICS regions running a stylized kind of presentation logic to link to the business logic. Remember, this business logic is the logic that is driving these enterprises' businesses. It's their core business capability. And so the more ways we can get to that logic, the more ways we can execute that logic, the more valuable it is to the business. But of course, the world we are in terms of IT and programming now is far different to when CICS started 60 years ago. We've gone through many fads and many revolutions of IT, be they message queuing, Java, the cloud, API enablement. And as each of these trends or each of these structural changes has come onto the horizon, CICS has changed and moved and evolved to allow those same applications that were written 60 years ago in COBOL or assembler to still be engaged with that new trend. So when message queuing became a thing, we gave CICS the ability to read messages off of a queue, take the payload of that message, use it to run a transaction, and when we get the response, put it back onto a message queue. We made the ability for Java applications to seamlessly interact with COBOL applications so that a transaction that was written 50 years ago in COBOL can now be extended by writing new Java code, and they all run within the same transactional context, the same application context. When I started working for IBM, the release we were working on was the first to bring web services. And again, that was another change in the architecture to when we started looking at service-oriented architectures that CICS needed to provide support for. So that these applications remain relevant, they can be reused, reinvented, and redeployed into modern enterprises. So I want to just quickly touch upon three key CICS technologies that we've worked on over the past couple of decades that have really changed the way that CICS applications work and modern enterprises see CICS. And the first one we're going to talk about is web services. Now, as I said, web services was added to CICS, and that was the first release I worked on when I joined with IBM. And I'll always remember my team lead saying to me, well, what we're trying to achieve is to allow existing applications to participate in service-oriented architectures as first-class participants without forcing the user to make any code changes. Hell, most of the time, the user shouldn't even need to recompile their application for this to work. And I sat back in my chair and went, wow, that sounds a bit like magic, if you ask me. That sounds awesome. How are we going to make that work? How are we going to take an application that was written 60 years ago that has no understanding of HTTP, doesn't understand XML, doesn't understand service-oriented architectures or SOAP, and how are we going to make it so that I can send it SOAP messages and it will be able to take the data, extract it from the XML, process it, and return to me an XML response if the application doesn't understand any of those things. Even, if I don't even have to recompile that application. That sounded a bit like, well, magic. But that was CICS TS version 3.1, and it did exactly this. And the way it worked was we took that COBOL program and we provided tooling to extract from it that business logic, that interface, the set of variables, the set of data that you needed to provide that program for it to work. And then we extracted that and we ran it through some converters. And what those converters would do would produce a WSDL file that would be, hey, this is how you interact with this new service. And it would define all of the files and all of the configuration that CICS would need to be able to transform an XML SOAP message that applied to that WSDL and to convert it into a COBOL data structure that the program could understand. And then do the same on the reverse. When it got that data structure, convert it back into XML and send it back over HTTP. A very simple architecture. It actually internally meant a whole load of changes. But what was the value of this? What was the value of this to a customer? The value of this to our customers was that they could take some business logic that was written 40 or 50 years ago. And just because it's old doesn't mean that it's not usable or not useful. These are the programs that were driving their business scalable. They were scalable, they were secure, they were transactional, they always worked. And you could now open those programs up to be invoked by brand new technology and brand new applications that could be written elsewhere. For the first time, I could write an application on a Windows x86 server, and I could call into CICS using a standard human readable format and drive a 50 or 60-year-old piece of COBOL code and get my answer without having to infringe on my security, my transactionality, and my scalability. This was CICS TS 3.1, and it was the biggest uptake of people upgrading their version of CICS that we have ever seen. Because it meant we could do more with the existing applications that we know and we trust. The next one is multi-language applications. If I was to ask any of you to write an application or a program, you would probably pick your favorite language, the language that you are most familiar with, maybe. Perhaps if the task was particularly specific in a certain area of computing, you might pick a language more suited to that particular problem. If you were doing something involving AI, you might choose Python, for example. And if you think of CICS, people obviously often think of COBOL, a business-orientated language. But CICS can also support high-level assembler code, PL1, C, Node.js, and Java. And it's supported those for the past, at least the past 10 years. And an application that runs in CICS can be made up of programs that are written in any combination of those languages. I can start off by running a Node.js application. And that Node.js application could run and end up invoking a COBOL program. And that COBOL program could link to an assembler program, then to a Java program, and back to COBOL. And even though we've changed language, we're still running that application within the same application context of transactionality, security, and management. So even though I may read or write to a file in COBOL and then link to a Java program, if that Java program detects a problem and decides it wants to roll back the transaction, that's just not rolling back the bits of the updates that the Java program made. It's rolling back the updates to the COBOL program and any other programs before it as well. They're all running as if they were one program written in the same language. Now, this sounds technically cool, obviously, but the value of this means that you can take those COBOL programs that were written, and if you need to, let's say you need to put a new API interface onto the front of them, or there's a new logging capability that you need to add to all of your applications, you're not restricted to having to write that in COBOL. Because if you look at the enterprise world now, COBOL developers are fairly difficult to find. There's not an awful lot of them. Java developers, probably a lot more of them. Node.js developers, probably even more. So I can now think about, well, I want to put I want to extend my existing application. Well, I could do that in Java. And I could use all of the capabilities that Java has to extend my application. And I don't need to worry about what the interoperability between COBOL and Java should look like, or how to run them inside the same context, because CICS is going to do all of that work for you. All you need to worry about is what the business logic is that you need to write. So let me give you some examples of what people have done with this kind of capability. So in the US, there was a US retailer that needed to create a new pharmacy payment web service. So they already had systems in place that would process pharmacy payments, but they, along with some new functions that they were adding to their tills, needed that to be invoked as a web service. And so what they did is they ran WebSphere Liberty inside of CICS, and they deployed a new service to CICS running in CICS Liberty, or WebSphere Liberty running inside of CICS, that linked to their existing backend code. We've seen customers who have done things like a UK retailer. I did some work with this customer. They had in their warehouses an application that was used by truck drivers who were coming in to drop off and pick up pallets of goods to send to stores. There was in the corner of the warehouse in an office a 3270 terminal, and that was driving a CICS application, and the truck driver would have to go to the terminal and log into the terminal and say which truck he was driving, what he was doing, which order he was picking, and then hit enter. And that would drive a transaction that would update the entire retailer's system to understand which goods were where and that they were in transit. Now, if you've ever worked in retail, you'll understand that the phrase time is money is very much true, in that they will understand every second that these people are what they're doing in their jobs, and they will work tirelessly to try and maximize that efficiency. And so they had the idea that, well, if instead of a terminal that the driver has to get out of his cab, walk to the office, process stuff on the terminal, and then walk all the way back, if we could cut that time down, we could save money. So what they did is they took that application and they turned it into a CICS web service. And then they wrote a new mobile app that ran on an iPad or other tablet device. And now it meant that the user would have that tablet in their cab with them. They would be able to use the application on the tablet to update what they were doing, the same kind of information that they entered on the 3270 terminal. But now they wouldn't have to walk all the way to that cabin and back. And that saved them money. And that saving was enough to pay in many times over the cost of the tablets and the software development to create that new part of the application. So it's not just about creating new applications, it's about modernizing those existing applications. Often ZOS and the mainframe gets a fairly bad rap for being old and legacy and past it. It's not. It's just that 3270 interface is what makes people think that the mainframe is old. And in reality, a lot of our leading customers have not been using 3270 interfaces for a very, very long time. Instead, they've been looking at other interfaces running off of the mainframe, but still driving that high throughput, scalable, secure, transactional traffic that they know drives their business. The second thing I wanted to mention, and we've touched upon it already, was the ability to run Java in CICS. Java itself is not a new language, I'm sure you're aware, but there are plenty of Java developers within the marketplace, and Java as a language has grown into a very capable language that can run on multiple platforms with many enterprise-ready frameworks to provide rich amounts of value to programmers. Now, we've supported Java and CICS since round about, I think version 2, maybe. But the support we had prior to version 5 was, well, we ran each thread that wanted to run Java code inside its own JVM. The way I like to think about this is the way that Java is meant to be written, or the JVM is meant to be used, is it's like a huge communal swimming pool, where every person in the pool is a thread. You have lots of threads in the pool doing their job, doing the jobs or the work they need to do, and you have a set of shared services like lifeguards or pool toys or diving boards. But prior to version 5 in CICS, this wasn't the case. Due to the limitations within the technology, we were only able to run one thread in a JVM at any one time. Because remember, that thread could be part of a wider unit of work with other COBOL or C or PL1 applications. And the only way we could ensure that transactionality was to have one thread in one JVM. And then when that thread had finished its work, we could reset the JVM and allow the next one to come in. Now, at this point, prior to version 5, the size of each CICS region was, or the amount of memory it used, was restricted to less than 2 gigabytes of memory, which meant that considering we need to have a single JVM for each application, or each thread for each application, this really limited the amount of concurrent JVMs that we could run in a single CICS region. And because of that, there was no way we could extend our Java support to all the wonderful frameworks and Java application servers that our customers probably could make an awful lot of benefit from. Because this, we would just blow the amount of memory we would need. And a lot of these frameworks already have the concept of shared pools or shared pools of threads. Well, we're only allowing one thread per pool, so that's not going to work for us. We needed to re-architect the way that Java was going to work in CICS. And this took us nearly 6 years. Do not underestimate the challenge that this was to ensure that we could have a multi-reentrant, multi-threaded JVM where each thread could be part of a wider, bigger unit of work. But we introduced that in version 5. So instead of having lots of pools, each with their set of shared services, which aren't really shared if there's only one person in the pool at any one time, we started to use the JVM in the way it was kind of designed to be. We could have multiple applications or multiple threads running in the JVM concurrently, and we called that a JVM server. Now, not only did this allow CICS, a single CICS region, to run a massive amount more workload than in the pooled JVM architecture, but it also allowed us to embed different runtimes into the JVM server. So we could take the open source WebSphere Liberty Profile application server, and we could run that inside of CICS, inside of our JVM server, which meant that a Liberty application that had been written outside of CICS could now be ported directly into CICS and call COBOL applications without any kind of network latency. And we had a customer that did exactly this. They had a set of COBOL applications running inside of CICS, and they had a set of Java Liberty applications, WebSphere Liberty applications running outside of CICS. And those Java applications would make network calls over to the the COBOL applications in CICS to get data, update records, and then come back. The problem is each time they ran those Java applications, they incurred network latency as they made that network hop and back. So they took the Java applications, they moved them from running outside of CICS to inside of CICS, and now they could benefit from that instead of a cross network call, a cross memory call. And they reduced their latency, they reduced the amount of time it took for them to process a transaction, and more importantly, they increased the amount of transactions they could process in a single period of time. So this really ignited the Java application world to, hey, now not only do we have to treat CICS as a set of services outside or that are network attached, we can now be called by COBOL applications. We can call COBOL applications, and we don't need to worry about how our transactionality model works. We don't have to worry about how the COBOL transactionality model works. CICS will handle all of that. We can now extend our applications to use Java in a really enterprise useful way. So apart from just having core Java capabilities, of course, we've tried to keep up with the latest versions of Java to bring those language capabilities into the JVM server. But we've also brought in the capability to create Spring Boot applications or Jakarta EE applications. This means that those frameworks, the reasons why Java is possible or that Java is desirable within the enterprise, they are also the same reasons that Java is desirable in CICS. And a lot of people do ask, well, why would I run Java in CICS? Because there are cases where people are writing Java applications that don't use any of the CICS APIs or any of the CICS COBOL programs that they already have available. They just want to run Java on the mainframe, and they will choose to run it in CICS purely because to them it looks like a CICS region. They don't have to know how to run Java on the mainframe. It's just a CICS resource that comes up. They know how to deal with that, and they can now run Java in there at the same time. It also meant from an IBM perspective that we brought a new world of developers into developing or extending CICS applications. And the problem was we'd kind of been working with COBOL developers for a good 50, 60 years, and now we had Java developers. If you put a Java developer and a COBOL developer in the same room and tell them to pick their favorite IDE or their favorite build chain or their favorite source code monitor, they're going to give you different answers. They're going to have different IDEs, different build chains, different tooling that they need to use. They're also going to have different methodologies. If I'm a Java developer, it is just natural for me to want to write unit tests, maybe do some test-driven development. If I'm a COBOL developer, I've not got the facilities to write unit tests. So I may not be writing some of those. So we had to change the experience for writing Java applications in CICS to appeal to Java developers. So we now have full Maven and Gradle capabilities for CICS. So I can write my application and I can use our own the IBM Maven endpoints or plugins to automatically not just compile my code, but deploy it to CICS and run it as well. So that these developers can use whatever IDE they want. They can manage their dependencies in the same way that they would manage any Java dependency, regardless of the fact that, well, this is one for the mainframe, one for CICS. And this has really allowed the amount of Java developers who are working on the platform to explode, because we're now not just looking at Java developers that have had the extra training to work on CICS. We're now opening the field up to any Java developer because the interfaces, the classes, the APIs, the build chains are just standard Java build chains, Java tooling. We'll talk quite a lot about the cloud being the future of applications and multi-cloud and hybrid cloud strategies. All of that is true, but at the heart of whatever hybrid, multi-cloud, or single cloud strategy you have, applications are still the core of business. If your bank is moving to a multi-cloud or hybrid cloud architecture, that's great. But they're still going to be wanting to run transactional applications at the heart of that application. Yes, they may have bits of it in containerized applications. They may have bits of it on the mainframe, but those applications are still at the core of what they do. And the ability to run those applications securely, transactionally, and in a performant way is still vitally important. These applications that CICS runs have been refined and extended over 60 years or so. They do what they do extremely well. And they are the applications that a business is betting their pure existence on. If someone were to wave a magic wand and remove all the CICS regions, modern economy would just grind to a halt instantly. You think about it. Every time you use your debit card, every time you use e-banking on your phone or you pay for something on your phone, you book a hotel room, you book a plane, there is a CICS transaction, probably written in COBOL, probably written over 30 years ago, running that transaction. And how many times does that not work? It pretty much always does. And several large clients are processing in excess of 1 billion transactions a day. Do the math. Divide that by the number of hours in a day, minutes in a day, seconds in a day. That's a lot of transactions, each one in its own security context, transactionally secure. If something fails or we've got two transactions trying to read the same file at the same time, doesn't matter. CICS handles all of that complexity at these levels of performance. CICS is so important that when IBM celebrated its centenary, they listed a list of IBM icons of progress, the 100 things that made IBM, or big things that IBM did, and CICS was listed as one of them. And there was a message that Steve Mills listed, who was at the time Senior Vice President of Software and Systems. 40 years young, with at least 40 more years to go. CICS is the backbone of so many companies around the world. When I think of CICS, I think of industry-leading transaction processing. I think of something that's really at the core of IBM's value proposition. CICS is clearly one of IBM's flagship products and a great part of our portfolio. Of course, he's going to say that he's biased. He was an IBM senior vice president. It's his job to say nice things about the products that we deliver. So let's go to someone else. Phil Manchester from Personal Computing magazine, which doesn't exist right now, I don't believe, but back in the 90s, it was a big thing. CICS is probably the most successful piece of software of all time. It's the mainstay of business computing throughout the world. Millions of users unknowingly activate CICS every single day. And if it was to disappear, the world economy would grind to a halt. So that was someone writing for not a mainframe magazine, but a PC magazine, saying how important this product is, not just to, the techies of the world, but to the world. And back in 2019, just before the pandemic, CICS celebrated its 50th anniversary. We're now 2024, so it means that CICS is 55 years old. Can you think of any other product that is 55 years old and is still that vitally important to the computing landscape? I really struggle to do it. So, CICS. It's like a vending machine. It's just an awful lot better. A vending machine has got sequential transactions, no security, very limited throughput. It only works in English, and it's got limited API support. Whereas the IBM ZOS mainframe and CICS allows you to run your established business logic that you bet your business on, extend it in the language of your choice, extend it and manage it as a single unit of work. High throughput and massive, unparalleled I/O capabilities, allowing you to run your trusted transactions securely across many different languages, across any different platforms. That is CICS, and hopefully you understand that's why you should care about it. Thank you very much.
Awesome. Thank you so much for sharing that presentation. I hope that a lot of you guys got a lot out of that. It was very, very interesting and a great explanation, especially for a lot of our newer ambassadors. Now we got a little bit of time left, so we want to open up. If any ambassadors have any questions at all for Will, now is a great time, whether it's on that presentation or other questions at all. Feel free to jump in or send messages in the chat.
So there was a question. Wonderful about the history of CICS. Are there any contemporary competing products like CICS? It's a really good question. So if you think about different languages, like if you take Java as an example, Java has a transactional framework called JTA. Now, you could say, well, I've got JTA. I can write my transactions in Java. Yep, you absolutely can. But that means taking all the logic you've got in COBOL and rewriting it into Java. That's a massive business risk for any business to take. So that restricts you from doing it. If you do need to change those applications, it's far more beneficial to say, well, we'll just extend them, keep them in COBOL, and write the new bits in Java. And that is a less riskier option. There was a product called Tuxedo that Oracle came out with. Now Tuxedo wouldn't I don't believe I can't believe it, don't think it ran COBOL. I think it ran C. Applications only written in C, and it would run on x86. And IBM CTG is a not CTG, TX series is kind of like a parallel to Tuxedo for the cases where you do want to run transactions on x86 or start in CTG TX series, sorry, and connect through to CICS running on the mainframe. We had a very good conversation with a huge retail customer in the US. They were looking to create a new application or a new service for their application developers, which was kind of like a name value pair database. Basically, because they were a retailer, they wanted to basically create a unique identifier for each item in each of their stores across the US and be able to look up or pull back that information, immediately. And you can think about the sheer amount of data that is, it's huge. And they sat with their IT peers, not just on the mainframe, but across their IT landscape. And they brought in several cloud-based or containerized-based applications to say, well, could you do this? And they all hit scalability problems with the sheer amount of data that they wanted to do. And so two of their guys sat down and said, right, well, let's try and build it in CICS. And they built it in CICS, and it ran at the scale that they needed and at a scale that could not be surpassed by any of the cloud users. And the reasons for this are that if you've got to remember here, we're updating data in a transactional way. So doing things like sharding a database becomes very difficult because you've got to maintain that transactional integrity across all of your shards. So you, at some point, have to deal with the overhead of purely synchronizing across those shards. With the mainframe, you can have that database in one place without sharding it, and you can still maintain that transactional integrity. You haven't got that overhead. So when you get to a certain level of scale and a certain level of throughput, the mainframe is your only option. There was a wonderful study by a large US bank who basically got a set of consultants in, not from IBM. It has to be said that they weren't IBMers, to basically say, okay, look at our business, look at our computing layout, look at the applications we run. If we started today from scratch, which platform would we end up on? Where would we end up? Would we be on the cloud? Would we be being distributed? Where would we be? And the consultants took all the data and they looked at their throughput and the characteristics of their application and said, if you started today, and this was, like back in 2020, it's not, no, we're not talking ancient history, we're talking fairly recently. If you started today with your restrictions, your amount of data integrity you have to maintain, and at your levels of throughput, you would end up on the mainframe. These applications aren't just on the mainframe because they were put on the mainframe 60 years ago when there was no other choice. These applications are on the mainframe because there's nowhere else to run them. Not at these levels of scale, not at these levels of data integrity. So that was a very long answer to a very short question. Sorry.
No, I think that was great, and definitely gave a lot of great background and information. I guess we haven't had a ton of other questions come in. Again, We still have time if you guys want to pop in questions.
Yeah.
But
We've just had another one. Can you talk about the career paths or various job roles we can find if we decide to get into Kicks? Ah, so I'm not sure if you mean like career paths um, inside of IBM or external to IBM. Um, but I would say that the roles that we need people. Okay, this is a good example. I was speaking at the Share conference, which is a mainframe user conference in the US, um, earlier on this year. And within the kick sessions, there was a young guy sat near the front, and he was about 1 or 2 years into his tenure working for a large US company, and he was one of their Kicks application developers. And every time we spoke to, or we had a presentation about Kicks, perhaps talking about some of the new capabilities, demoing some of the cool stuff you could do with Kicks, this guy was just popping ideas constantly. Can we do this? Why can't we do this? We could use this to solve that problem. And it was that energy and that vitality that shocked me, because he was like, look at all this cool stuff we can do. We can make a big difference to our business if we adopt some of this new technology that we're seeing that we've already got. So, from an external point of view, we want people who, you know, understand the world that is around Kick. So understand cloud, understand connectivity, understand DevOps, and help to bring those practices to run with Kicks as part of them, because the technology is more than capable of doing it. But we need bright young people to bring that energy into those teams, because these people have been probably working on Kicks for a long time. They need that energy. They need that youthfulness to say, no, we're going to change. We can change the world. We can build a better application. We can make more value for our company. Internally, the Kicks team is, as good as it's ever been. Developing the next release of Kicks, working with our customers, working with you guys. It's been an absolute privilege and pleasure to talk to you today and kind of talk to you about what Kicks means. I've worked on Kicks since I started in IBM. As you can tell by the grey and receding hairline, I've been there a fair while. And Kicks is what I've done for a very, very long time. And I'm very much the kind of person that is motivated by having interesting work to do. If I've not got interesting work, I get itchy feet. I want to go elsewhere. I want to do something new. And I've stayed in Kicks because it's been interesting. I've done Kicks testing, I've done Kicks engineering, and now I'm a senior technical staff member for Kicks. So yeah, really has been interesting.
awesome. I think that was again very helpful and some good information for these students to hear as they're going on and throughout their undergrad and into their careers, that the energy is needed, and there's certainly opportunities to make an impact. Um, if there's not any other questions, as always, we can move to take our photo, and still give you guys a few last seconds to, if you think of anything. But so if everyone can turn their camera on, and we'll take our usual Z photo. We have a few new faces, so I'll demonstrate now, but we always make a Z. We do this, and then you just flip one hand up, and that's how you do your Z there. I'll be taking a
Oh, that's cool.
screenshot, and I don't have more than two hands, so I'll just be doing a little zoom reaction here.
I can take the photo if you like,
Okay,
Josh.
yeah. Zoe, if you want to take the photo,
How are
give
we
us the
doing that again?
countdown.
That's
Everybody got
If
it?
your video is mirrored, it can be a little bit more challenging.
All right. 3, 2, 1. Perfect.
Awesome. Well, again, Will, thank you so much for joining. I think this is a super helpful session, and I hope you all got a lot out of it. Just a few reminders for our new ambassadors. Make sure you're working on your concepts badge and getting that in as soon as possible. Let us know if you need any technical help or have any issues. Plenty of resources to help with that, as well as to our other ambassadors. Never a bad time to continue sharing and advocating about mainframe to other students, and think about ways to get other students involved, get them signed up onto Z Explore so they also can learn a little bit of technical knowledge. The year is winding down for most of us, especially all the Northern Hemisphere ambassadors. But we do have a graduation ceremony in 2 weeks, so keep an eye out for the weekly email that will have information about that, as well as a calendar invite. And as always, let us know, keep us updated about your progress, any work that's going on in your campus. And yeah, we're here to support you guys. But again, thank you, and I hope you all have an excellent weekend.